Okay, friends, in today's video, we'll be exploring the critical world of domain name system attack types and the various DNS record types that underpin internet functionality. By the end of this video, you'll have a comprehensive understanding of both DNS attacks and records, equipping you with valuable knowledge to enhance your cybersecurity awareness. So, let's get started.
Okay, friends, today is about DNS spoofing attacks. First, DNS stands for Domain Name System. Sometimes this is referred to as DNS cache poisoning. This is basically a cyber attack that manipulates the domain name system to redirect network traffic. Basically, what DNS does is translate human-readable domain names like youtube.com into an IP address that a computer can understand. DNS spoofing is maliciously associating a domain name with a different IP address. Okay, let's explain this in a different way. Imagine the internet is a huge city, and each website you visit is like a house in that city. Usually, to find the house that you are after, you would use a map. DNS is the map for the internet. When you type youtube.com, your browser asks the internet for the DNS, the map, for the address, like the house number of where that website lives online. Now, this is where spoofing comes in. So imagine if someone gave your browser the wrong address on purpose. Instead of going to the right house, you end up going to a different one. This is basically what happens in a DNS spoofing attack. Someone with malicious intent gives your browser the wrong DNS information to direct you to a fake website. They do this because they may be trying to trick you into giving away your password or personal information. Thank you for watching the video all the way to the end. I hope you found it useful. Stay safe, and I'll see you in the next one.
DNS stands for Domain Name System. DNS amplification attack is a form of denial of service attack strategy that weaponizes how DNS servers work. This includes sending large amounts of DNS requests to the server beyond its normal capacity. The requests are somehow spoofed to appear to be coming from a machine that the server knows. When that happens, the server responds with a large number of responses back to the victim's machine in order to disrupt their systems. This type of attack can stop users from accessing essential services. To mitigate the impact of such an attack, organizations can implement the best practices for DNS and network security configuration settings. Implementing detection and response plans is also another step to distinguish between authentic network traffic and irregular patterns that indicate a persistent attack. I hope you found this video helpful. Remember to use a VPN. Stay safe, and I will see you in the next one. DNS is often referred to as the phone book of the internet. This makes it a foundational part of the internet. In normal circumstances, firewalls let DNS traffic in and out. Malicious actors take advantage of this and use DNS requests and responses to encapsulate and transmit data payloads. These payloads can include sensitive information or malware. Hackers do this by registering a malicious domain that includes the malware. When visited by the target, they can be directed to a server controlled by the hacker. This is where the hacker can establish a remote connection inside the target's network. The consequences of a successful DNS tunneling attack can be severe, ranging from unauthorized access to the infiltration of critical infrastructure systems. Implementing robust DNS security measures, such as DNS monitoring and anomaly detection, can help organizations detect and prevent DNS tunneling attacks. I hope you found the video helpful. Stay safe, and I will see you in the next one. A subdomain is a subdivision of a main domain. For example, in the domain blog.example.com, blog is the subdomain of the main domain, example.com. Subdomains can be used to organize different sections of a website or to host separate services. DNS subdomain takeover is a type of attack that occurs when an attacker exploits misconfigured DNS settings to gain control over a subdomain. The takeover works like this. An organization creates a subdomain. It often points to an IP address or a specific service. However, if the subdomain is no longer needed, or if the service it points to is taken down or deleted without removing the DNS record, a vulnerability is created. This is what malicious hackers look for when scanning websites. Attackers can use various tools to discover subdomains associated with a target domain. If they find a subdomain that is not properly configured or is pointing to a resource that has been decommissioned, they may have an opportunity for takeover. This is where the name DNS subdomain takeover comes from. From this point, attackers can register that subdomain with the same provider. This allows them to create a service at that subdomain and control it completely. Once they have control of the subdomain, they can host malicious content like phishing pages, redirect users to malicious sites, exfiltrate sensitive data if the subdomain was associated with an application that has security weaknesses or damages the reputation of the original domain owner. I hope this video helped you understand the DNS subdomain takeover vulnerability. Stay safe, and I will see you in the next one. Did you know attackers can use your own browser to breach your network security? This technique is called a DNS rebinding attack, and it's a serious threat to businesses. A DNS rebinding attack is a technique used by attackers to bypass browser security and exploit networks behind a firewall. This is a browser vulnerability that sometimes can be used to attack IoT devices or to gain a foothold inside the enterprise perimeter. This attack can compromise security by exploiting the trust relationship between the browser and the internal network, allowing an attacker to execute malicious actions like data theft, service manipulation, or further network intrusion. This attack works like this. Browsers have same origin policy that prevents websites loaded from one origin from interacting with resources from another origin without explicit permission. DNS rebinding attacks are designed to work around the restrictions of the same origin policy. The attacker needs to control a malicious DNS server by setting it up to answer queries for a specific domain such as example.com. Using techniques like phishing, the attacker tricks the victim into loading the malicious domain example.com in their browser. When the victim's browser requests the IP address for example.com, the attacker's DNS server initially responds with the real IP address of example.com. The attacker configures the DNS response with a very short time to live, for example 1 second, ensuring that the browser quickly expires the record and makes a new query. After the time to live expires, the browser makes another DNS request for example.com. This time, the attacker's server responds with an IP address from the victim's local network. Since the browser still sees the requests as originating from the same domain, example.com, the same origin policy restrictions are bypassed. Now the attacker has a foothold. The attacker can now interact with internal resources using the victim's browser. Potential actions include extracting sensitive information, disrupting business operations, performing unauthorized activities, and laying the groundwork for more extensive attacks. To defend against DNS rebinding attacks, restrict JavaScript execution, configure browsers with DNS pinning, and ensure all private services use HTTPS. Friends, as you can see from this video and other videos on the channel, most attacks start with a simple phishing strategy, so stay alert. I hope this video has helped you understand this attack, how it works, and how to defend against it. If you found this helpful, don't forget to like, comment, and subscribe for more cybersecurity insights.
Have you ever wondered how the internet knows where to send your emails or load your favorite websites? It's all thanks to DNS records, the unsung heroes of the internet. DNS, or the Domain Name System, is a foundational technology of the internet that translates human-readable domain names into machine-readable IP addresses. DNS acts as the internet's phone book, enabling seamless interaction between humans and the underlying infrastructure of the web. Without DNS, using the internet as we know it would be far more challenging. DNS records, also known as zone files, have different types and formats of data entries stored in the domain name system that define how requests for a domain or subdomain should be handled. Each record type serves a specific purpose, such as directing traffic, managing email, or verifying domain ownership. These records enable DNS to perform its primary function, translating domain names into IP addresses and providing other essential information about domains. DNS record types are important because they help with routing traffic, email handling, security, and service configuration. The first type is an A. Record. A. Record stands for address. This type maps a domain name to an IPv4 address. This type of record only supports IP version 4 addresses. The main use of this record is for IP address lookup. Next, we have quad A record. This is similar to an A record, but maps a domain to an IP version 6 address. IP version 6 offers more addresses than IP version 4. This type of record supports modern networks utilizing IP version 6. Following that is the CNAME or canonical name record. This type points a domain or subdomain to another domain name. It acts like a nickname or alias for a domain. Instead of pointing directly to an IP address, like an A record, or creating two A records, it points one domain name to another domain name. Imagine you have the main website and its subdomain. Instead of managing a separate IP address for the subdomain, you can create a CNAME record. This helps with consistency, ease of management, and load balancing because it helps distribute traffic by pointing to dynamic services like content delivery networks. Afterward, we have the MX or mail exchange record. This specifies the mail server responsible for receiving emails for a domain. This means it directs emails to your domain mail server. These records work with an email server to enable the setup of personalized email accounts. Additionally, we have text records. This type stores arbitrary text for various uses, like domain ownership verification and security. These records are frequently used in various email authentication protocols. Moving on, we have NS or name server record. This type specifies the authoritative DNS servers for a domain. It ensures queries for a domain are directed to the correct DNS servers, meaning it directs Internet applications, such as web browsers, to the location where they can retrieve the IP address for a domain name. Similarly, we have CAA or Certification Authority Authorization Record. This specifies which certificate authorities are allowed to issue certificates like SSL/TLS for a domain. A certificate authority is an organization that verifies website identities and links them to cryptographic keys by issuing digital certificates. This enhances security by reducing unauthorized certificate issuance. Another important type is the PTR or pointer record. This is the opposite of an A record. It resolves an IP address to a domain name, essentially a reverse DNS lookup. Instead of linking a domain name to an IP address, PTR records associate an IP address with a domain name. When a DNS query starts with an IP address, the PTR record identifies the corresponding hostname. This is used in email server configurations for spam prevention. Next is the SOA or Start of Authority record. This provides essential information about the domain, including the primary name server, admin email, and DNS zone properties like refresh rate. Then, we have SRV or service records. This type is used to specify the location of a particular service within a domain. It provides information about which server offers a specific service, as well as the port number and priority for accessing that service. When an application or client queries the DNS for an SRV record, the DNS responds with the details of the server, including the port and priority. The client then connects to the specified server to use the service. Common uses of SRV records include voice over IP, instant messaging, and Microsoft services. Furthermore, we have DNAME or Delegation Name Record. This is a similar record to the CNAME record, but applies to all subdomains. Essentially, it redirects an entire domain subtree to another domain. Additionally, there is the DNS Key Record. This type stores public keys used in DNS security extensions to verify the authenticity of DNS responses. This ensures integrity and prevents spoofing. Finally, we have NAPTR or Naming Authority Pointer Record. This record provides dynamic DNS capabilities, often used in telephony and internet services. It allows you to set dynamic rules for how your website processes requests. These were the most known DNS records that you would find in a DNS server database. If you found this helpful, give this video a thumbs up and subscribe for more cybersecurity insights. Remember to use a password manager. I will see you in the next one.